window correct. I can have the Q&A open. You don't see it. Good stuff. Window correct. I can have the Q&A open. You don't see it. Good stuff. Oh, you have some echo though.
I turned it off. Hi, folks. We'll start in a few minutes. Well, probably 1 minute. All right, let's do it. Hello, folks. Welcome to Tetrate's August Zero Trust webinar, Zero Trust with the Service Mesh. This month's installment comes on the heels of the publication of the final version of NIST Special Publication SP 800-204B, Attribute-Based Access Control for Microservices-Based Applications using a
Maybe we should start using shorter names. It's a mouthful.
I say nothing. The new publication is co-authored by Tetrate founding engineer and today's speaker, Zach Butcher, along with Ramaswamy Chandramouli of NIST and Aradhana Chittal of TIAA. SB 800-204B provides deployment guidance for building an authentication and authorization framework within the service mesh that meets the twin requirements of one, mutual authentication and communication between any pair of services, and two, a robust access control mechanism that is both expressive and scalable at the same time. In today's talk, Zach will discuss the implications of these latest NIST security standards, what they mean for you as practitioners, and how they fit into the broader landscape of zero trust architectures. With that, I'll turn the mic over to Zach.
Cool. Hey, thanks everybody. And just to remind, as with all of these, this is kind of an open Q&A. So please do ask questions, use the Zoom Q&A functionality there, and I'll answer some of them kind of as I'm going or towards the end, depending on how they fit in or not. So with that, let's kind of get rolling. There's a couple different things that we'll talk about here today, but I wanted to start at maybe a very easy place, or maybe not so easy, but at least I think maybe the right place to start, which is what is zero trust full stop, right? And this is, there's a bunch of different definitions around, there's a bunch of marketing around. For me, when I try and explain it to folks, I try and boil it down to these four pillars. And I'll show you kind of how I back this in some of the literature in a minute. But in my mind, the four kind of key pillars for a zero trust architecture are, what are you doing pre-runtime? How do you build your code artifacts? What are the proofs there? How do you deploy those artifacts? Who can do deploys? Who can deploy which things? What systems are allowed to deploy into what places, and which artifacts are they allowed to deploy? All of that stuff, right? Everything that happens from a developer writing code and checking it in somewhere to producing an artifact that gets deployed and run in production, right? Is that kind of pre-runtime bit. And there's a whole wealth of stuff there. We'll talk about that at the end. The second pillar then is the set of runtime controls. This is the bread and butter of what we discuss in some of the SPs that I'll talk about. But really there's kind of 5 pieces here, which is encryption in transit, service authentication and authorization, and end user authentication and authorization. And those are the kind of primary runtime aspects of a zero trust system. The third piece then is the continuous proof, or the continuous assertion of the system state, right? So it's not enough just to have policies in place once. We need to know that those policies are actively being enforced for every single request in our system, right? And we should be able to notify and alert and take action when there's anomalies, when there's things that we don't expect, when the system does not behave as you would normally think. And this is obviously something that, for example, a mesh can help with quite a bit as well, and it tees right off the runtime control. So we'll talk about that a little bit. And then the fourth piece is managing this stuff, right? So who can deploy what when? Who can change the runtime configuration, which is security oriented or even traffic oriented? There's a really blurry line between reliability and security. Who can go and see the proofs, who can change those, that kind of thing, right? The whole kind of audit compliance side as well is wrapped into this kind of management pillar. So in my kind of worldview, these are the four primary pieces that make up what a zero trust architecture is. So with that, hey, look, I had some nice points there, right? So what's allowed to go, our encryption auth and auth-z, what data are we gathering from the runtime system, what actions can we take for those, and then who can change it, when was it changed, why, what was the effect. So where are we today? Today there are a bunch of different kind of documents from the government, in particular governing zero trust. From the U.S. federal government. The first and maybe most important one for us to talk about is 207. And that is the basic zero trust architecture document, right? And it lays out a whole bunch of different stuff. It's an incredibly valuable document to go read. There's a lot of good stuff in there. But these 7 points are kind of what they declare to be the basic tenets of zero trust architecture. And if you squint at those, I won't read them to you, but if you squint, you should be able to identify, hopefully, those 4 pillars embedded in here, right? Maybe we talk about the pre-runtime a little bit less in the 207 paper, but the other pillars should be very evident there, right? And this is all stuff that looks very reasonable on its surface, right? And so 800-207 is kind of the starting place when we want to talk about what zero trust means from the federal government's perspective. And I would argue it's a pretty good place to talk about it from even just private, if you're looking at how you do this in your company, you don't necessarily have government directives or similar that are binding you. This is still a good place to start. So teeing off, and I'll just highlight 1 or 2 things here, actually. The first thing I want to highlight is the importance of dynamic policy, right? This idea that we want to be able to make decisions in context, and we want to be doing that at least per session. I would argue we want to be doing it better. We want to be doing it even per request in that session, ideally. And I'll talk about that in a little bit. That we're doing auth and auth-z for everything, right? So not surprising, but that's kind of where we start, right? And it lays out the essential logical components that you might need to achieve this. And keep in mind that policy enforcement point, that PEP is important. We'll come back to that in a minute. I'll touch on that some. But if we carry on, and again, I want to kind of I'm giving this background as context for how we kind of arrived at 204B. So following on the heels of 207, we have now the 204 series of papers. And the 204 series specifically governs microservice security. So everything in that 204, 204A, B, the upcoming 204C, we'll talk about at the end of this call, are all oriented around microservice security, with 204, the first entry there, laying out the general strategy for around protecting microservice applications. And this is independent of the service mesh, although they do talk about a service mesh a little bit in this paper. It again lays out very simple and straightforward things that you would expect but talks about how they need to be applied in the microservice context, right? And again, it's a list that is very similar to what we'll see in the subsequent 204 papers. It's a list that I just talked about in the pillars. Parts of this come up in 207 as well, right? That we need end user auth in, auth z. We need a service, an idea of a secure name. This gets developed in the subsequent papers into that formal service identity. We need to be able to do authorization on that. We need to be able to secure the communication in transit, right? Using things like TLS. We need to be able to get visibility into it. And I'll point out that 204 specifically talks about a variety of different traffic management features in the context of security, things like circuit breaking, things like rate limiting, for example, are really useful when viewed from the lens of security, not just application traffic or reliability, right? These are things that help prevent a variety of different attacks. For example, circuit breaking can be, and rate limiting together can be very helpful, for example, in mitigating certain classes of DOS attacks at the application layer. Following 204, which Muli wrote, 204A is where I started to get involved in the process here, along with Muli, who wrote 204. And this is where we start to talk about the service mesh in more depth. And in 204A, we've talked about a little bit in some of these webinars before, but it really talks about kind of the primary content of the paper is a bunch of recommendations for really deploying and operating a service mesh securely. As with 204, none of these are groundbreaking or novel. Our point here really is to introduce the idea of the service mesh, the architecture, and describe some of the how to think about it from a security perspective. And again, establish that all the stuff that you did before in a healthy system, you want to do here too, right? We may implement it a little differently. It may map a little bit differently. And that's what the SP recommendations go into, how to achieve some of these controls in using, for example, Istio or any service mesh that has kind of the baseline set of features. But again, the primary purpose of this SP was really to say, look, all the good stuff that you did before, you need to do here. And we can talk about the specific recommendations if people have questions, and we'll look at 204Bs in a little bit more detail. And so that then brings us into 204B. So 207 set the stage with general what is ZTA and lays out a variety of different architecture, lays out the primary components, it lays out one architecture, lays out the logical components of that architecture, as well as some of the key tenets behind it. 204 establishes microservice security strategies in general. 204A discusses them in the context of the service mesh. And 204B extends that and starts to talk about how we can do attribute-based access control, ADAC, I'll call it, for short throughout here. And discusses what that runtime architecture is, discusses how it aligns with the overarching zero trust architecture that's described in 207, where the service mesh is the PEP there, the policy enforcement point, and makes the case that we want to start to use the service mesh to do access control on behalf of applications, right? And we make a bunch of specific recommendations, just like in the 204A and in 204, which come along with the slew of recommendations. 204B as well has a bunch. Again, none of these are novel or crazy. They are taking what are known and accepted practices and kind of mapping them over to the mesh, right? Basic stuff like, hey, if you're going to use the service mesh to do encryption in transit, you should really root the certificate tree that is being used to manage those, to do that encryption in transit in your existing PKI. So you can manage it just like any other intermediate key in the rest of your PKI, right? Super basic, super simple. It makes intuitive sense. This is a lot of what we're trying to do in the 204A, 204B, these early papers, right? Establishing the kind of baseline. All kinds of good stuff there. You need to have an authentication policy. You need to have authorization policies, that kind of stuff. But those are kind of bearing the lead a little bit, because there's really kind of one salient set of ideas that I want to highlight out of 204B that I think are the most important, and they're really tucked all the way at the end of the paper as well, which is the idea that first, the sidecar proxy, which is acting as our policy enforcement point, is a reference monitor. We'll work the slides here, right? And reference monitor is something that's non-bypassable, right? So we have every request going through it, every connection going through it, right? It needs to be protected from modification. The SP spends a little bit of time talking about how you might do this. This is something that does wind up being kind of platform specific, and there's a lot of devil in these details. But in general, we can use kind of different technologies to assert that the image that's running is what we think it is. We in the SP outline, for example, requirements on how the sidecar which is the reference monitor, communicates with the control plane to get its configuration, so it can't be tampered with similarly. And the third requirement there for reference monitor is that it needs to be able to be verifiable and testable. And so if we have all those things, then we can say that a component is a reference monitor. And I want to be very clear here. When we talk about a reference monitor in security literature, it's kind of an ideal to strive towards, right? And so the goal is that in our deployments, the proxy forms this reference monitor, right? Non-bypassable, can't be modified. We can verify and test that it's correct as it is enforcing our policy over every request that goes through. That's the ideal. The security kernel, the next statement is just kind of a tautological almost, right? The security kernel is the piece of the system that implements the reference monitor, and right. And so in this world where the sidecar is the reference monitor, then the mesh overall, including the control plane and its configuration, becomes the security kernel for our system. Right, the security kernel again is talked about a bunch in research. It's that kernel really comes from the operating system kernel and the idea of building security into the operating system. This is the legacy of the security kernel research from the 1970s. Is why we have the different Linux security models today, for example, with kernel security enforcement there of users and different things like that, right? Same idea. The kernel there applied a little bit differently though, right? We're using it, but same idea. And so we go one further and we say, therefore, because we have this reference monitor, which can be a security kernel, another important idea of the security kernel is that it's a focused bit of code that we can look at and audit. And so we can have a higher assurance in it, right? Because of that, we want to start to use the mesh, and sorry, that's a typo, that should be the mesh, not the mesh, to enforce service to service as well as end user to resource authentication and authorization, right? So 2 layers there. Can these workloads communicate regardless of where they're running? Traditionally, that would be in a perimeter security model, we would enforce that with the good old adage, reachability is authorization, right? If I can talk to the endpoint, then I have permission to call it, right? That's not sufficient. That's not in line with the zero trust tenets, right? We need to enforce a service identity as well as an authorization policy that is dynamic, that takes into account runtime attributes, right? When we're deciding if 2 things can communicate or not, right? By the same token, we want to do it at the application layer, looking at what is the end user accessing in the application logically, right? That can be done with things like dots and claims at a coarse grain level, but it can also be done, and we can use the sidecar to enforce much more fine grain, where we maybe delegate out to another authorization system that knows, that can read, for example, the resource out of an action. We can look at a URL and pull the resource out, right? And you can look at the end user credential that was authenticated by the proxy, and that can be handed back to the authorization system, and both of them can be used together to make an authorization verdict, right? And then the sidecar can act as a policy enforcement point and enforce that verdict at runtime, right? And all of that together, because the mesh has a smaller footprint in terms of code for us to audit, because the controls are consistent across every application of the fleet. This becomes safer, we argue, than embedding than what we've done traditionally, which is embed that authorization into the application logic. So these are the kind of really key sets of ideas that came out of 204B. Let me just sidetrack one minute here, because there was a good question that came up. Sorry, there we go. If we run back a little bit, somebody asked a question around Istio's authorization policy and NGAC. And the answer is no, they're not mutually, fundamentally, Istio's authorization policies are a type of RBAC, a type of role-based access control. They don't look quite like what a normal maybe RBAC API might look like. If you went one version earlier in the Istio APIs, it would be exactly a traditional role-based access control API. Instead, Istio today kind of folded them together. We can talk about why if people are curious. But NGAC and ABAC in general is a fundamentally different approach to access control compared to role-based access control that you might be used to in Kubernetes or in Istio, for example. Even cloud provider access control APIs try to look like an RBAC, a role-based access control, even though really under the hood they're implemented as an ABAC. So no, today Istio does not implement NGAC compliant policies, although you can, through kind of a Rube Goldberg machine, get there, which is, and there are white papers, there are research papers that are published about this, but NGAC has a lot of really cool access control capabilities that make it very valuable over some of the existing ABAC systems and even some of the existing RBAC systems. One of the primary pieces there is that it has a set of primitives around audit and explain that we can use to kind of query the system about the state of objects and users. You know, which users can access, you know, give me the list of users that can access this object. Give me the list of objects that a user can access. Tell me why. What policy is it that allowed this particular user to access that particular object? Using some of those underlying APIs, which are part of NGAC, NGAC itself is an ANSI spec and was standardized by this same group at NIST that we were working with to write these papers. In that spec, they outline those operations. Using those operations, you can actually produce an ACL, an access control list, right? Just a simple flat list. And that can actually be mapped very easily to an Istio authorization policy. So if you, for example, wanted to go and use NGAC, today you can't plug it into Istio directly, but instead you could do that synthesis using those capabilities of NGAC to construct an access control list. There are research papers that talk about how you would do that efficiently. That is an efficient operation to do in NGAC. And then you can use that, for example, to enforce access control policy at runtime. This is something that our product, Tetrate Service Bridge, which uses NGAC, is starting to do now. We've used NGAC under the hood for a long time for various different access control elements in the product, but we're starting to use it in exactly that way that I just described, to be able to manifest policies that we can talk about why they work, how they work, but still implement them using some of the Istio primitives over time. So hopefully that answers the NGAC question there, right? The other half of that question, somebody asked, are there going to be new authorization plugins, for example, in Envoy with the external authorization API, so that Envoy will be able to do NGAC directly? And the answer is yes, we are working on some of that stuff. In general, though, there are not a standard set of NGAC APIs today. That is something we're hoping to standardize with the group, but that is not something that is present yet. And the follow-on question to that was, hey, can we point to the papers that talk about this translation? For sure, we can send some of that stuff out. All right, but again, the really kind of salient idea here in the SP is that by pushing the security into the mesh, we can operate things more cheaply, more efficiently, and more safely without having to go into all the application code and without having this kind of wide footprint when we want to go change policy, because we have a central control point from the mesh. And again, we kind of buried that at the very end of the paper. So if we look at some of the actual controls, this was not, I didn't want the TSP on there. Sorry, I was trying to list just the controls there. A lot of it is pretty straightforward. Again, nothing is crazy novel here today. Whoops, sorry. You know, things like the meshes signing certificate in your existing PKI, right? Mandate and have a system that continuously asserts that there's an authentication and authorization policy for every workload that is running in the system, right? Some of the 4.3 controls are really Kubernetes or other kind of platform level controls, right? Make sure that when you're deploying containers, they have read-only file systems, right? That's just a general good practice, not really mesh specific, but does come up a lot in newer cloud environments where it's easier for us to have this capability compared to on VMs, for example, right? Going on down the list, you know, we talk about the need for service level authentication and how MTLS and SPIFFE can be used to achieve that, and what some of the specific settings you might want to use there are. We talk about the need for secure naming if you're going to be doing the service naming, right? 451 talks about the mandate to have authorization policies in place. 452 talks about how proxies and the control plane need to communicate, as well as and how that needs itself should be authenticated and authorized, right? As well as what data the system should be producing, and how the system should handle things like a JOT, for example, in Istio and Envoy. If we talk about end user credentials. And then finally, we talk about some of the default policies that should be in place in the system in 4.6. So with those, that is the meat of 204B. We can talk. I'm super happy to dive into more depth as people have questions about it. Again, a lot of the specific controls that are there, a lot of the specific recommendations that are made, I should say, are again pretty basic things that you look at and go, this is a good practice. We think we should have authentication and authorization policies across the board. We should have these things, right? Because again, the primary purpose of this is not to break new ground, but to try and standardize known good things and talk about how they map to the service mesh. As we carry on through this series, we expect to be able to talk about more and more interesting things that you can start to do with the mesh from a security perspective. I will say this is pretty cool. One of I've talked about it before at some different conferences, so we can link some of those videos. But for example, a group that we work with in the U.S. Air Force uses the service mesh to provide to implement SSO, single sign-on, and behind that SSO, they actually do both authentication and authorization for applications that are deployed in the mesh. You know, and so this is kind of one of the key ideas that led to this 204B paper. As well, and led for the recommendation for us to start to push for that across the board using the mesh. Talking about some of the future-looking things, I also want to announce and kind of talk about for the first time that 204C is coming as well, which we're pretty excited about. This one, in general, we're trying to keep this 204 series pretty practical and hands-on. There's a huge pain right now, both across the federal government as a result of the executive order mandating Zero Trust architecture be adopted by every single government agency, as well as a bunch of folks that we talk to in, you know, for example, financial tech and other in health, for example, other very highly regulated industries. They are all watching these SPs pretty closely Because again, it's very, or not again, but because it is very likely that these security standards are going to move into industry consortium standards as well. This is what things like PCI DSS do, right? And so to that end, we're trying to shore up the 204 series to do a couple different things. One, again, be very hands-on and practical in addressing the need for folks trying to understand how ZTA works practically for them now in a microservice deployment, as well as kind of lay out, so we want to talk, how's it going to work? How can we start to use it? And then what are some of the other pieces that are maybe not necessarily service mesh based, but a lot of the, for example, DevSecOps bits that we want to talk about are really around that pre-runtime component. When I laid out those 4 pillars, everything in 204B here just about really is around runtime controls, right? We talk a little bit about some of the management of those controls, but by and large, we're really talking about runtime controls. With 204C, we're going to start to talk about some of the pre-runtime controls, right? For example, discussing some of the ideas around the CI/CD pipelines that we want to use for deploying, and some of the safety practices there, right? And we'll kind of expand on that again with the goal of being a relatively useful document for folks as they're looking at going and implementing a ZTA with concrete technologies, right? The other big thing to note here is we're actually writing pretty fast as far as these SPs go. It's not common that we see this many produced in this short a time frame. 204A came out in 2020, 204B coming out in 2021, just a few weeks ago. 204C should be out by the end of this year, we're hoping. Right now, we have drafts that are in flight. We're expecting public comments, hopefully in about 4 weeks, but certainly in about 6 weeks, we'll have it out. With, again, the intention of actually publishing it by the end of the year. That is the main stuff I wanted to talk through. 204B, we can certainly dive into and look through if we want some of the kind of specifics of the paper. I know it's just riveting content for everybody to read through PDFs with me. So I would love to know, do we please ask questions away in chat attendees here. Otherwise, we can start to kind of look through some of the pieces here if we want to look at some of the specific controls. One of the things that's nice around this one, by the way, is that we do have the recommendations collected together in the appendix here. So it's pretty easy to see a nice, concise list of what they actually are. Again, nothing here is earth-shattering. All of these things, though, you should be doing. Most of them manifest in the installation configuration. Some of them are going to manifest per application, per service that's deployed. And this is where you want to start to make sure that you have systems that are looking at the state of the world and asserting that is correct, right? That is kind of that third pillar there, that continuous assertion of system state, right? So some of these, for example, are relatively easy to enforce at deployment time, right? So for example, Kubernetes has high-level policies that we can set, and you can use things like admission controllers to enforce, basically all of these AHLC recommendations, for example, must not run as a privileged container, must have a read-only file system, some of those basic ones, right? Those you can typically assert once when the workload is being scheduled, and you have something like Kubernetes that's going to guarantee that for the life cycle of the workload. Some of them, though, you get into are not and need to be asserted continuously. So, for example, a policy object relating to authentication should be defined that requires MTLS everywhere. Hopefully, you can do that once. That is something that, depending on your setup, you may need to do assert continuously. As we go on down, right, again, pretty basic stuff. One of the questions that came in here is that, so suppose I have an existing identity management system like Active Directory or LDAP, right? how do I start to fit that into, how do I integrate this into a ZTA-based system without jeopardizing the zero trust parts, right? And this is a really awesome question, because there's a lot of kind of subtlety here. The best answer I can give you is that you want to use, I'll talk about Istio specifically, since that's both the reference implementation that we use in the papers as well as the one I have the experience with. This is where we do have first-class integrations. So, for example, specifically for things like Active Directory, today we're seeing people interact with them primarily via OAuth or OIDC flows, right? I know that that's not exactly an answer to your Active Directory LDAP question, although a lot of the services for those now do offer OIDC endpoints. This is a place where, and we discuss it in the SP, I want to be clear, it is expected that you're actually going to integrate with an external system. And so this is something that the SP, we unfortunately can't go into in depth and recommend, just in the context of the paper, recommend specific technologies. But as an example, if you're using Istio, one of the things that we see used quite a bit is the Istio ecosystem auth service extension, which implements Envoy's external authorization APIs, but then backs it with the general OIDC flow, right? And so that is a shim server that can be used to start to integrate the service mesh, and specifically Envoy as an enforcement point with an existing identity provider, right? Now, how your mileage goes with Active Directory and LDAP is still being worked on at the moment, right? But the general principle here that we talk about in the SP is the idea that you are going to want to delegate out to those existing systems to make authorization decisions. I think we discussed that idea primarily in section 4, but we also discussed it up in section 3, if I'm not mistaken. But yeah, that idea that you need to integrate with your existing system is there because you have to have an incremental approach to adopting a ZTA. It's not going to be a big thing, all at once thing that happens. One of the other questions that came in is, we've talked about service to service and user to service authentication and authorization. So with respect to service, certs work well for east-west communication, because it's kind of all part of one big application, right? But for example, in the B2B case, we're using API keys today. So how do API keys, what's the NIST opinion on API keys with respect to ZTA? Do they establish it? Are there other alternatives there? So one thing, let me just be very clear. Here, I am giving you my opinion, not the official NIST opinion. The official NIST opinions are what's in the documents, right? Anything that I'm adding over top is my informed opinion based on helping write these, right? So I can say that, yes, we actually do talk about API keys directly in some of the earlier documents in the series. Specifically, if we go back to 204 itself, the original kind of strategy document, you'll notice this one's a decent bit longer than the other ones. If we get down here, we actually do talk about API gateways specifically, and API keys are specifically addressed here. Generally speaking, though, our stance here is that, yes, you're probably, so first off, there's a couple different things that are happening. So when we talk about service to service authentication and authorization, it does not necessarily have to be MTLS based, although yes, we do recommend that. And yes, that is the default inside the mesh for east-west. However, API key and one-way TLS is also a very valid mutual authentication method for two applications that are communicating, right? And in fact, a variation of that flow, not exactly an API key, but a similar connection-oriented token. I know API keys will typically put per request. But for example, when an Envoy connects to Istio, we don't have mutual certificates there, because Istio's control plane is the one that needs to give Envoy the certificate, right? So we have this bootstrap problem. In the way that we address this is exactly analogous to your B2B case, which is Istio serves a one-way certificate, a simple TLS certificate, just like any normal HTTPS website that you would go to. And that proves the identity of the control plane. That's what the client facing, that's what that server certificate does for any client, right? So then to mutually authenticate and authorize, we need the client, in this case, Envoy that I'm talking about, to give some credential as well that we can authenticate. In Istio, that is going to take the form of some node local, some pod local proof, like the service account certificate or a certificate from the VM, maybe that's being the workload is being run on, right? And we'll use that as a proof of the workload to issue an identity. This is analogous to API keys. So all that to say, yes, having a traditional one-way TLS server and using some request-oriented token API keys are totally fine, is a very valid way of identifying one service to another. And it is important, again, to remember that an API key is going to identify a service. It is not an end user credential, right? So end user credential is happening up at L7. The API key, even though it's an L7 artifact that we would attach to the request, usually does not identify individual users, and instead is going to identify applications. And we also need to look at the user, right? So API keys are exactly analogous to service identity. Do use them, totally valid way. Very often what we will see is either an exchange of token on the internal side, or we'll have some component like an API gateway that asserts that API key, and then we trust the services behind it, or we drop down to using the mesh behind it, and we lose that notion of B2B client identity. If you need to keep that B2B identity that came from the API key, and you want it internally, there's a whole bunch of different tools to do this. A, if you want it, you're probably already doing something today. B, what we see very frequently is something like taking that API credential and transforming it into something like a JOT, a JSON Web Token, that we can attach to the request that's cheap to authenticate locally and that can include some extra data. So hopefully that answers the question there around kind of service outside the context of East-West. One just meta note I'll make is that I want the whole idea behind Zero Trust is that East-West, North-South don't exist anymore. I didn't put it in the slide deck, but maybe I should have here at the top. In my mind, the key thing to think through here is, what if I expose this workload to the internet? Right. What if I take this thing that is running in my infrastructure and I were to make it publicly, and I were to give it a public IP address, right? So anything can go talk to it. What does that mean, and what are the implications for my security model, right? That's really, and the answer should be nothing changes. The answer should be my security model worked before, and now that the workload is publicly addressable by anything on the internet, my security model is still sound because I was not using access as the proxy for authorization. And I was not using strictly the IP5 tuple or similar to make a decision on something being trusted or not. Instead, we're depending on that L7 identity, both for the service and for the application. However it is that's appearing, whether that's mutual TLS or some other token like an API key or any other kind of token you might want to attach. Alrighty, other questions, comments, concerns, rebuttals? Otherwise, I know we're a little bit short today, but this was kind of the primary content, and these were a couple of excellent questions there at the end. Great question as well. Is within the U.S. government, is NGACS being mandated? And the answer is it is not being mandated, but it is being recommended. And this is a subtle distinction, but this is what an SP does. So SPs, special publications, do not mandate any behavior. They are strictly a set of recommendations that are published by NIST for the federal government and for general industry to consume, right? What takes that recommendation and creates a mandate is something like the executive order. So in this context, the executive order that I'm talking about is the Biden cybersecurity executive order that was signed earlier this year in the wake of the Colonial Pipeline ransomware attack. That executive order mandated Zero Trust and outlined quite a few different documents to reference for folks looking at that. Certainly RSPs, the 800 series, is in the set of recommended guidance as a result of the executive order. 204B says you should be using NGAC to do this access control, but it is not mandated that NGAC be used by the government. So hopefully that's the hopefully that makes sense, right? So NGAC not being mandated, but is being recommended. And then I think there was one other question that came in as well. Okay. So I'll touch on a little bit of just context around NGAC in general, because I think there's not a ton, right? So one of the questions is just how popular is NGAC? Maybe I'll take a step back and just say, what is it even? I mentioned very briefly here, NGAC is, actually, I don't talk about it very briefly here. NGAC stands for Next Generation Access Control. When we talk about access control systems, there's a couple major families. I talked about this earlier in the call, the idea of a role-based access control. That's one family of access control systems. Attribute-based access control is a bigger one. And it turns out anything you can do in an RBAC, you can do it in an ABAC. Today, when we talk about standards for ABAC systems, there are two. The primary one that everyone is familiar with is XACML. That is the not just de facto standard, that is the NIST ANSI standard for ABAC. The second NIST ANSI standard for ABAC is Next Generation Access Control. And if we go around, we should be able to find it. Here is, yes, the ANSI, the INSITS standard for NGAC. So NGAC itself has been standardized. What is described in that standard is how the graph, and so the fundamental novel piece here, sorry, just to spell this, because we haven't talked about NGAC in depth, I believe. Most attribute-based access control systems, and even most RBAC, role-based access control systems, are based on set theoretics. And so the underlying engine that powers them is set-based. And the operations that we can do on them are the set theoretics operations, unions, intersections, things like that. The problem is that sets are flat and they don't track causality. They don't track the relations between things, right? As a result of that, it can be hard to understand how policy is authored. What NGAC does is twofold. One, it formulates attribute-based access control as a graph theoretics problem, not a set theoretics problem from the math treatment of it. So basically it lets us think about the world as a graph rather than sets. This gives us a whole bunch of different tools that we didn't have before. Secondly, then, and so how those graphs can be constructed is very important for the semantics of NGAC. And so the spec talks about the graph, the components of the graph, how you're allowed to relate users and user attributes and object attributes to each other and what those relations mean. And then it goes further and outlines some of those operations that I talked about a little bit earlier, the audit and explain operations, the why was this access allowed, what set of policies were in place that allowed it. The reason every time I say that I draw this little arrow with my fingers is because I'm used to doing it on a whiteboard where we're literally tracing the path through the graph. And that has semantic meaning, right? We can talk about Zach as a member of Tetrate. And an admin, we have the specific identity, assigned a policy that said Tetrate people can access these resources on GCP. And that GCP project is part of the organization that Tetrate can access, right? And so that manifests in the graph, and we can walk through directly. How those relations map, part of the standard. How the operations audit and explain walk the graph to get out semantic meaning for humans, part of the standard there. What is not part of the standard today is the set of APIs that are exposed, the check, explain, the runtime access control check API, not standardized. But the fundamental underlying characteristics of the system, the graph, how they relate, what relations are available, and then the fundamental operations that exist on an NGAC-based access control system are all present there. Then the other question is, how widely used is it in industry today? And the answer is it's still pretty new. So it is not really widely used at all. The standard itself was written a few years ago, but we've not yet seen widespread adoption. This is one of the areas where Tetrate is trying to work, and we are partnered with NIST and actually have a collaborative research agreement with NIST around the development of NGAC. For us, I can say our entire product is actually written in exactly the way that 204B describes, where we use the access control system. Our actual services are very dumb. All the smarts live in the policy enforcement point and in the access control system, and our services behind it are very dumb. This is another very fun question. What about OPA as an access control system? OPA constructs don't quite support a graph as a way of defining policies. How does OPA relate to ZTA? All those things, right? So OPA is in this context a policy enforcement point. Well, OPA is a couple different things. So the agent acts as a policy enforcement point, or a policy decision point, I should say. I apologize. It renders a decision. You have to implement the enforcement, whether that's using a service mesh, whether that's making a local RPC call to the agent and then getting a verdict back and implementing it in your application. You have to implement the enforcement. OPA doesn't. Now, what about OPA as an access control system in general? In general, I am not a huge fan because of the policy language itself. Especially as you get deep into access control systems and how they work, the fundamental problem, I guess the fundamental problem of computer science is human-computer interaction, right? The fundamental problem when we're talking about access control and how we author policies is, how do users understand the policy they just wrote, right? I have this policy right now, and here's the diff, here's the new policy, because we have some declared a policy, or it's the OPA policy object in Rego, right? Whatever it is. How do I understand, me, the policy author, me, the reviewer, the security owner in the system, how do I understand what the effect of this policy is going to be before and after? And this is the fundamental question that we have to answer when it comes to access control systems, because the runtime parts are complicated and cool and interesting, and you can do novel things there. But fundamentally, at the end of the day, it's an implementation detail. And the real way that people interact with the system is via the policy language. The problem with OPA is that Rego as a policy language is incredibly expressive, which is a good and a bad thing. I can do stuff like make a web call. I can do stuff like load a database. I can do a bunch of different things that may look innocuous in a line of policy, but actually have kind of bigger impact on the external system, right? And these kind of side effects can make it challenging to understand what a policy is going to do before and after you offer it. And so for that reason, because Rego can be effectful, because there are things like database calls and external dependencies and things like that, you can't prove anything about any of the policies, right? Maybe you can prove things about a specific policy, but as a general rule, we hit the halting problem. We can't across the board declare things about a policy written in Rego, or at least not maybe as much as I personally would like. As an example of a different option, eBPF is an example of a language where we can, for entire categories of scripts, assert behavior about it because of the limitations in how it's written, right? So, there's analyses, there's things that we can do that you can look at a policy and make it understandable in that context, right? With OPA, we can't quite. So, is it a good tool to use in an organization? Yes, it is, if you don't have an existing policy engine to be able to rely on. But my caution would be, be very mindful what types of scripts you're allowing, and you want to keep things very simple. You don't want to go off the deep end there. So, there's not anything inherently there with OPA around zero trust or not. It's a totally fine tool to use to implement parts of the system, but do be mindful of the expressivity that it allows, because that's a double-edged sword when it comes to access control. You want something that's just smart enough, but not too smart. You want something that's smart enough to make it easy to write policy, but not so smart that it's easy to write complicated policy. Would be maybe the advice there. One other thing that I'll just touch on, there's one other novel piece of NGAC that I skipped over, and it's the idea that it can actually decide across many classes of policy. This is a really subtle concept. So RBAC is one class of policy. ABAC is one class of policy. If you remember back to your like formal languages days, if you're a computer science student, we have the idea of a hierarchy of languages, the Chomsky hierarchy. In the exact same way, there's a hierarchy of access control systems that is described by the set of policy that you can express in the system. RBAC is less expressive. Anything that's an RBAC can be expressed in ABAC. The novel piece with NGAC is that it is able to make policy decisions across multiple classes of policy in a single verdict. I can write an RBAC style policy. I can write a time of day location based policy. I can write this, that, and the other policy. I could maybe have an OPA policy that I delegate out to OPA to render a verdict that comes back to NGAC. And in one traversal of this graph, there's some subtlety in how you might model OPA in the graph, but it can be done. With one traversal of this graph, you can assert a policy decision across all of those classes of policy, even if there's different documents that describe them. Incredibly powerful. So in that sense, it's not NGAC versus OPA. NGAC is a more general system that OPA could be one class of policy that gets evaluated. And there's trade-offs there. We can talk about that in more detail as well. How do you handle databases with zero trust, right? How does the connection work? How do these things go? This is an area where we're still actively kind of doing implementation work, doing discovery work to try and decide. So fundamentally, the answer is the same as for the other ones. Your database should be encrypting everything in transit. It should be asserting the identities of the workload that is talking to it. And it should be getting some end user identity that is asserting as well. Today, for the most part, people are at least encrypting the database connection. That's a gimme. Any cloud provider database is doing it. If you're running SQL yourself in some flavor, you should be running it with certs. They are serving one-way TLS, right? So that at least handles one side of the service identity. Most SQL implementations today do not assert the identity of the client, except for at the connection level, right? And so today, basically the way that works is exactly that, right? So we say that, I told you before the API case and the API key for north-south traffic. The legacy database is effectively that, right? So the database is serving a one-way TLS. You do have some credential that you're using to connect to it that should be asserting it. That's unfortunately per session, not per request. You can get at least some of that, right? So then the question is, so hopefully you can start to formulate how we might, begin to look at a database, for example, and how we would start to ZTAify it. The answer is no different than any of the other ones, right? Now, the problem is there's less tooling available. This is actually another area where the service mesh is actively working. So some things around, just general putting Envoy in front of the database is an option there, and it gives you some of the capabilities that we talked about, including the service identity, right? We can't yet do end user credentials on Postgres stream, for example. This is also an area where there's ongoing work in, for example, Envoy and Istio specifically, right? So one of the things that's ongoing is support for SQL wire protocols as an L7 protocol, just like HTTP or Redis or Mongo in Envoy today. And so that's one of the other ways that we'll start to be able to attack kind of legacy databases more fully, right? The final thing I'll mention is that this is actually a novel area where we are working with NIST still. So there is NGAC, Next Generation Access Control. There is a version of that called NDAC, Next Generation Access Control for Data, I believe. And the key idea there is that you can start to use NGAC to answer per cell access questions, right? And so you can imagine that eventually you can have an envoy that's SQL aware, that's doing NDAC policy, doing per cell access control, per column, per column per row in a SQL database. When I say a cell, on the data that's streaming out of the database server, right? And so that might be how we would have achieved that in the full minute, in the fullness of time. Today, how do you start doing it? Make sure your database connections are encrypted. Make sure you're using credentials to connect to it. If you are using a mesh, start to look at the runtime costs of putting a proxy in front of the database there, so you can start to get some of the other features kind of for free around the stronger notion of service identity than just the one-way TLS. Eventually be able to start to do some of that L7 policy on the stream. With that, we're just about out of time. So any last one question or so before we kind of run out? Otherwise, excellent set of questions. Thank you all. These have been really interesting to talk through. Nope. All righty.
Thanks, Zach. That was awesome. And I think there was a number of questions these were great answers, and we'll do a wrap up and make sure that we get all of the questions sort of packaged up. There was some questions about pointers to research, et cetera. So we'll definitely give you a follow up. And I learned a ton, even though I get to listen to Zach talk about this stuff a lot. Thank you very much. And for everyone else on the call, it was great to have you here.
Well, thank you all. And sorry, just the last final bit here. As I was asked about NDAC, there it is. But awesome. Thank you all. Thanks for having me. Thanks for being an excellent audience. I hope everybody has a wonderful day.